The Carnegie Institution for Science audio press release for November 11, 2015. The Giant Magellan Telescope Organization breaks ground in Chile. Leading scientists, senior officials, and supporters from an international consortium of universities and research institutions gathered on a remote mountaintop high in the Chilean Andes to celebrate groundbreaking for the Giant Magellan Telescope, or GMT. The ceremony marks the commencement of on-site construction of the telescope and its support base. The GMT is poised to become the world's largest telescope when it begins early operations in 2021. It will produce images 10 times sharper than those delivered by the Hubble Space Telescope, and will address key questions in cosmology, astrophysics, and the study of planets outside our solar system. Quote, "We're thrilled to be breaking ground on the Giant Magellan Telescope site at such an exciting time for astronomy," close quote, says board chair and director of the McDonald Observatory at the University of Texas at Austin, Dr. Taff Armendroff. Quote, "With its unprecedented size and resolving power, the Giant Magellan Telescope will allow current and future generations of astronomers to continue the journey of cosmic discovery," close quote. The GMT will be located at Carnegie's Las Campanas Observatory in Chile's Atacama Desert. Known for its clear, dark skies and outstanding astronomical image clarity, Las Campanas is one of the world's premier locations for astronomy. Construction crews will soon be busy on the site, building the roads, power, data, and other infrastructure needed to support the observatory. The unique design of the telescope combines 7 of the largest mirrors that can be manufactured, each 8.4 meters or 27 feet across, to create a single telescope, effectively 25 meters or 85 feet in diameter. The giant mirrors are being developed at the University of Arizona's Richard F. Karras Mirror Laboratory. Each mirror must be polished to an accuracy of 25 nanometers or 1/millionth of an inch. One giant mirror has been polished to meet its exacting specifications. 3 others are being processed, and production of the additional mirrors will be started at the rate of 1 per year. The telescope will begin early operations with these first mirrors in 2021, and the telescope is expected to reach full operational capacity within the next decade. Quote, "An enormous amount of work has gone into the design phase of the project and development of the giant mirrors that are the heart of the telescope. The highest technical risks have been retired, and we're looking forward to bringing the components of the telescope together on the mountaintop," close quotes, says Patrick McCarthy, interim president of the GMTO. The GMT will enable astronomers to characterize planets orbiting other stars, witness early formation of galaxies and stars, and gain insight into dark matter and dark energy. GMT's findings will also likely give rise to new questions and lead to new and unforeseen discoveries. The GMT Organization Board of Directors officially approved the project entry into the construction phase in early 2015, after the 11 international founders committed over $500 million toward the project. Founders come from the U.S., Australia, Brazil, and Korea, with Chile as the host country. Quote, "With today's groundbreaking, we take a crucial step forward in our mission to build the first in a new generation of extremely large telescopes. The GMT will usher in a new era of discovery and help us to answer some of our most profound questions about the universe," close quotes, says GMTO board member and director of the Harvard-Smithsonian Center for Astrophysics, Dr. Charles Alcock. Quote, "We're pleased to celebrate this momentous milestone with our Chilean colleagues, our international partners, and the astronomical community," close quote. The Giant Magellan Telescope, or GMT, is slated to be the first in a new class of extremely large telescopes, capable of producing images with 10 times the clarity of those captured by the Hubble Space Telescope. The GMT aims to discover Earth-like planets around nearby stars and the tiny distortions that black holes cause in the light from distant stars and galaxies. It will reveal the faintest objects ever seen in space, including extremely distant and ancient galaxies, the light from which has been traveling to Earth since shortly after the Big Bang, 13.8 billion years ago. The telescope will be built at the Carnegie Institution for Science's Las Campanas Observatory in the dry, clear air of Chile's Atacama Desert, in a dome 22 stories high. GMT is expected to see first light in 2021 and be fully operational by 2024. The telescope's primary mirror combines 7 8.4-meter or 27-foot diameter circular segments to form an effective aperture 24.5 meters in diameter. Each mirror segment weighs 17 tons and takes 1 year to cast and cool, followed by more than 3 years of surface generation and meticulous polishing at the Richard F. Karras Mirror Lab of the Stewart Observatory of the University of Arizona in Tucson, Arizona. Funding for the project comes from the partner institutions, governments, and private donors. With the independence for nimble pursuit, Carnegie scientists tackle some of the most profound challenges in modern science, fundamentally changing what's possible for us, our planet, and our universe.